Okay, good morning, good afternoon, good evening. We are very pleased to have you join us today and welcome to the Intro Bootcamp. This will be the first bootcamp of a series of events that we will have for all the Algo devs. Today with me is the great Joe Polney. Hi Joe, how are you, my friend?
Hey Camilo, hey everyone. I'm doing great. Looking forward to starting off our intro boot camps, and already right away I want to plug our beginner and our intermediate boot camps for Python and TypeScript. So we have a whole lot of content, not only today, but a whole lot of content in the pipeline for developers.
As all you know, this is the year for the Algo devs. So today is just the first step to start your journey as an Algo developer. And before we start today's session, I want to invite you to join us on the next bootcamp that we will have the next week. So hold on a second. I will share with you all the bootcamps that we will have during April and May. So hold on a second. So as you can see, today we start the intro bootcamp. We will show you how you can use the SDK to start creating accounts, creating assets. The next week, we will have for the first time the beginner Python bootcamp. And over there, we are going to create a digital marketplace. So you will be able to create your own assets and then list them, and the people will be able to make offers, and you will learn how you can do it using Python. As you know, the last week we launched AlgoKit 2.0, so this is the perfect scenario for you to keep learning about how you can create smart contracts using Python. And then we will have the beginner Typescript. We are going to create the same project, but this time we are going to use Typescript. And here we have the file of Typescript, the great Joe Polney. And then we will have the intermediate ones, and we're going to repeat the Python content on early June. So we have a lot of content for you guys. Please help us to share the registration info. I'm going to share on the link, on the chat, the link so you can register for the upcoming sessions. And we are not ready to start the intro bootcamp. It's important to mention that these sessions are recorded, and once it's finished, you will automatically receive the link to the recordings. And later, we will upload the content to the Algo Devs YouTube channel. If you are not subscribed yet, I invite you to do it. So I don't know, Joe, if I'm missing something or we are ready to start.
No, I think we are ready to start.
Okay, so all yours, my friend. And
Okay,
thanks
great.
all the people that join us, and we are super excited to having you all here.
Perfect. Thanks, Camilo. So before we actually get into the content, I just want to do a little bit quick housekeeping on Livestorm. So Camilo mentioned the recording for this specific event will be available to you automatically. And then later we'll also be posting content to a YouTube that we'll be showing you here. So how it's going to work is I'm going to be playing a video that was pre-recorded that contains all of the coding and presentation content for today. As that is playing, I'll be in the Livestorm event being able to answer questions, and if we need to pause the video to talk about something, I can do that. So if you haven't used Livestorm yet, I can see a bunch of people already chatting, but in the bottom right, there's a chat button. This is where you can go to chat with other people in the bootcamp and just have general conversations. But then if you have a specific question about the content that is being shown or about Algorand, right next to the chat icon in the lower right is also going to be the questions tab. The questions tab is the better place to go when you have a question. I'll be trying to monitor both. I'll have some colleagues also monitoring as well. but go to the questions tab if you want to make sure that your question gets answered. And so I'll be answering questions live throughout the event. And then if there's a need to pause and kind of talk about a concept, then I can do that. And then after we get through all the content, I'll come back and we'll talk a little bit about, all the new content we just learned, what we're going to be doing in our next intro session, and how we can prepare for that, and just answer any questions that you guys might have. If you are here today, you should automatically be registered for the next intro session as well, which is going to take place Thursday. So you don't need to worry about that. And then links for registration, we'll talk about future boot camps again after we get through all the content. So if you want to register for future boot camps, we can discuss a little bit more what that will include after we get through the intro content today. So again, as I mentioned, I'm going to be playing a video. I will still be here live answering questions in the questions tab and monitoring the chat. So let us know if you do have any questions. How it's going to be laid out today is we're going to start off with a little bit of a presentation, just kind of talking about Algorand in general in case you're new to Algorand. And then we're going to be jumping into some code. Now, if you are already an Algorand developer, don't worry, you're going to learn something new today. We're going to be going over the brand new Algorand client that is now a part of AlgoKit Utils, which is our SDK for interacting with the chain. So there's going to be something new for everyone here. And this piece, it's very new. It actually hasn't even been officially released yet. So if you're here in the bootcamp, you're going to be the first ones that get to use this new software. It's going to be pretty cool. And of course, as we go through, you're going to ask questions. And if you have to drop off, in the middle of a session, because it's recorded, no big deal. You can catch up on the recordings after we finish the live session. So let's go ahead and get started. And I will share that video, and let me know if there are any issues. Sometimes Livestorm can be a bit funky with playing videos. So if you're having an issue where you're not seeing the video, I recommend trying refreshing, or maybe switching the browser you're using. But hopefully you should be able to see this video. And just a heads up, it will end kind of abruptly because I'm going to be doing a different ending than the pre-recording. So I'll be coming back on once it's over. The video itself is about 45 minutes. Like I said, we might pause, so it might go a little bit longer. But for this bootcamp and all our bootcamps, we're going to try to keep it under an hour and a half. Again, this one's runtime is around 45 minutes, and then we'll have some time at the end for questions. So with that out of the way, let's go ahead and get started.
Hey everyone, I'm Joe Palmy, an engineer over at the Algorand Foundation. This is an intro to Algorand. This video is specifically targeted to developers that are interested in building on Algorand. Even if you already know how to build on Algorand, you might learn a new thing or two here because we're going to be using a brand new library for JavaScript for interacting with the chain. If you are brand new to Algorand or just brand new to blockchain, don't worry, we're going to be starting with the very basics and keeping the code very simple once we do get to it. But before we even get to the code, let's talk a little bit about blockchain and Algorand and why you might want to use it. So the biggest thing to talk about when it comes to blockchains is the blockchain trilemma. And these are kind of three pillars that make a strong blockchain, and that is decentralization, scalability, and security. Now in Algorand, we have solved all three of these areas. Our chain is decentralized, it's secure, and it's scalable. Now, I can tell you about the decentralization and security by going into our network topology and talking about our low-level consensus protocol and going into all the nitty details, but I'm not going to do that today. Today, I'm just going to be focused on developers. So we're going to be getting into scalability and a little bit more depth. But before that, I just want to quickly mention that if you do want more information on our decentralization and security, one good starting place to go is to look up Silvio Macaulay. He is the founder of Algorand, and he has led the development and research team, Algorand Technologies, for building the Algorand protocol. And it's what enabled us to solve the blockchain trilemma. A little background on Silvio. He's an MIT professor, Turing Award winner, and he's contributed to a lot of primitive features that are used not just in Algorand and not just in blockchain, but in cryptography as a whole. So he was a contributor to zero knowledge proof, verifiable random functions, and the pure proof of stake consensus protocol, which is what Algorand uses to be decentralized and secure. Now, so if you don't take my word for it, take Silvio's words for it. Now, the important thing that we as developers want to know about any technology before we integrate it into our stack is how fast is it, right? How does it perform? Can it do what I want it to do? And when we're talking about blockchain, these are kind of the three things that we talk about. TPS stands for transactions per second, and this is all about how many things can I do in a second on this blockchain. So on Algorand, for example, we can handle a lot of transactions, but it's good to quantify that, and we'll talk about that in just a second. It's good as a developer to know how much room you have to scale. Another really important thing for blockchains is block time. Block time means how long it takes for a block of transactions to get added to the network. So every time we transfer funds or call a contract or do something on chain, it has to get included in a block. So that thing doesn't happen to the rest of the world until they can see that block. So the time it takes for that block to get added to the chain is very important, because ultimately as developers, that's the time that we have to have our end users wait until we can tell them what actually happened. Then finally is the time to finality. If you're new to blockchain, this might seem like a bit of a foreign concept, but if you're familiar with other chains, you're probably familiar with the idea of like reorgs. And on Algorand, we don't have any reorgs. We don't have any soft forks. Our time to finality is instant. And if we take a look at these other metrics, you can see that we also have 10,000 TPS, 2.8 second block time, and instant finality. So what does that mean for you as a developer and your end users? That means that whenever you do something on chain, it takes 2.8 seconds to get added to the chain. And once it's added to the chain, it can never revert back. So in other chains that don't have instant finality, you could run into what is called a reorg. And this basically means I think a block is added to the chain, someone else thinks that block isn't added to the chain, and there's a disagreement, and maybe the block that I think gets added actually gets removed and isn't on chain. And you can imagine in real world scenarios, having this reversal of transactions or transaction order can be detrimental and just add a lot of headache to you as a developer. So with Algorand, once something happens on chain, you can be sure that it actually happened, and you don't have to account for scenarios where it gets reverted. So these three things, these three tenets of performance alone are a great reason to start building on Algorand. As I mentioned, of course, we're also secure and decentralized, and there are plenty of great online resources for that. I don't have all the time in the world today to get into that. So again, I encourage you to go look up the pure proof of stake protocol and Silvio Macaulay's work and learn a little bit more about the cryptography behind Algorand. But as a developer, here are the numbers, and this is why Algorand can offer such a compelling developer experience. So let's talk a little bit about some of the layer one features we have in Algorand. We know it's fast, but what exactly can you do? So the first one is we have native tokens. Native tokens means that when I want to represent some asset, whether it's a fully digital asset or a real world asset that I want to represent on chain, I don't need to use smart contracts. On many other chains, I need to write code to create tokenized representations of assets. On Algorand, this is a feature that is supported natively by the protocol. This enables a couple of really cool features that we'll get into a bit later once we get into the code. But the core idea is that we don't need to write smart contract code, and we can be guaranteed that the protocol is doing the accounting of our native tokens properly. We aren't relying on smart contract logic. We're just relying on the core infrastructure that powers the Algorand network. Now, the other great feature of Algorand is this concept of atomic transfers. What this enables is it allows multiple different transactions to occur, but only if all the other transactions that we want to group with it also occur. So this means that if I'm sending you some tokens and you're sending me back some tokens, I don't want those tokens to leave my wallet unless I can be sure that you send me back those tokens. And this doesn't just apply to token transfers. This applies to smart contract calls and all sorts of complex things that you can do on Algorand. So with this, again, we're eliminating the need for smart contracts to do these core primitive features like having atomic groups of transactions. And this is very important when we think about reducing centralization, reducing trust, and reducing the overhead that it takes for you as a developer to implement these core features. And finally, Algorand is powered by the AVM, or the Algorand virtual machine. If you've heard of other blockchains, you've probably heard of the EVM, or the Ethereum virtual machine. A lot of blockchains use the EVM in order to power their smart contract execution, but on Algorand, we decided to improve upon the EVM and make our own virtual machine. This allows for a lot of unique features on Algorand, and importantly, allows Algorand to be super scalable. The AVM is a big reason why we're able to have such quick block times and instant finality, and a really high TPS. And as time goes on, these things are only going to get better because the AVM was designed to scale. Okay, so that's my quick pitch on Algorand. So let's go ahead and jump right into the code, get our hands dirty, and see exactly how we can use all these cool features that Algorand has to offer. Okay, now we're ready to jump into the code. Now, to get started for this intro video, what we're going to do is we can just head straight over to the Algorand Bootcamp organization on GitHub.
I did see there was a question on reorgs and TPS and how all of this works. So I figured I would do a quick overview of that. So when it comes to a blockchain, there are many different metrics that you can do to measure that blockchain, how fast it is, how well it will perform. And so in many common blockchains, a very common metric to measure that is TPS, or transactions per second. And this basically means how many transactions can our blockchain handle when we as developers are using it, right? So this isn't just for one user. This is how many transactions can the entire blockchain use, right? And we'll learn a little bit more about what a transaction actually is and the things you can do in transactions as we get into the coding portion of the content. But the key is that the TPS is generally kind of like the speed limit of a blockchain. And so on Algorand, 10,000 TPS, it puts it much higher than some other popular chains like Ethereum or Cardano, where we can handle a very high level of throughput. And to give some context to that number, like a big thing on TPS is scalability, right? So not only can I use it now, but how can I use it in the future? Right now, Algorand is averaging at around 100 TPS, and we can go up to 10,000. So we have a lot of room to grow and a lot of room for new developers to come on and build the chain. Now, and the other thing we covered here was instant finality. And what instant finality means is that so in any blockchain, there is, well, it's called a blockchain because you have a chain of blocks of transactions that a bunch of different computers agree on. And so in a lot of blockchains, you have this thing called a reorg. What this basically means is I, as a node in the network, think this is my chain, but you, as a node in the network, might think that your chain looks like something else. And eventually, we have to agree on which chain we think is the right chain. And so what this means is that we need to have ways to have different chains happening at once, and then eventually agree on one chain. The time it takes to agree on one chain is what we call finality. And on Algorand, that is instant. So what that means is that we don't have scenarios on Algorand where I think the chain is in some state and you think the chain is another state, another person thinks it's another state. On Algorand, once I have a blockchain, once I have a new block, everyone else in the network also agrees on that. And what that means is that as a developer, you get the latest blockchain and you can be assured that that is the blockchain. If you see a transaction in that blockchain, then you know that that is final. So if you have like an application that you depend on, you're waiting for a payment from a user, you don't have to wait multiple rounds, or you don't have to wait an hour to know that that transaction actually went through. It just happens right away, right now in 2.8 seconds. So not having reorgs and a high TPS means that Algorand is scalable, and it honestly, it kind of works like you would expect a blockchain to work. Once a transaction's in the blockchain, it's in there. It's immutable. It's not going to be reverted. Whereas on other chains, when you have reorgs, it's possible that you might think of transactions in a chain, but then it gets moved somewhere else, and that can really impact real-world solutions. So instant finality is really big for Algorand, in particular for developers. So let me go take a look at some other questions. So see a question, what is the comparison with Move and MoveVM? So Algorand uses the AVM or the Algorand virtual machine. So we right now are not Move compatible. Maybe we will be in the future. Right now, our main language that we support is Python. So we support writing contracts and just raw native Python. In today's bootcamp, and we also support TypeScript as well. In today's bootcamp, we're not going to be writing smart contracts. We're just going to be using SDK in TypeScript to go over some basic chain interactions. And then we'll have later bootcamps if you're interested in writing smart contracts and actually using more features of the AVM. You can do that in our later bootcamp. So right now, we are not Move compatible. We're not Solidity compatible. We have our own languages, and right now the main one is Python for Algorand. This is native Python that you can use to write smart contracts. And question about native tokens. So what this means is, so of course we have our own token called Algo, and this is the protocol token that is natively supported by the protocol. And we also have the ability, however, to create our own tokens. So every chain has their own protocol token, like Algo for Algorand, BTC for Bitcoin, ETH for Ethereum. But then a lot of other chains, like Ethereum, for example, has their own tokens that people can create on the network. So USDT is a good example of that. You also have like Dog with Hat and all these like meme coins and stuff. And those are all tokens that anyone can create on the network. And typically how you do that on other chains is you write a smart contract to represent that token. This means that every token you interact with, it's code that someone wrote and you're kind of just trusting that code does what you expect the token to do. On Algorand, users, anyone in the network can create their own token. So you can create your own fungible token or non-fungible token or NFT. And when you do that, you don't need to use smart contracts. And because you're not using smart contracts, you're just relying on the native protocol. You don't have to worry about whether a token can be trusted or not, or whether it actually behaves like you expect it to. Because tokens are a native feature of the blockchain, they work as part of the native consensus in Algorand. So you can always be assured that your accounting, your balance, how those tokens can move is guaranteed by the consensus of the network and not controlled by some smart contract that someone wrote. So native tokens in this context is referring to the ability to create fungible tokens and NFTs without using smart contracts. Okay, and then I see two questions I'll answer. One, what main programming language do I need to know? So TypeScript and Python are our main two languages. Python is right now our main language for writing contracts. We also have a TypeScript smart contract language as well. And then for writing our front ends in this bootcamp, today we're going to be using TypeScript. And then in our front ends, we're also going to be using TypeScript as well for both Python and TypeScript smart contracts. So those are the two main languages. And then is there an official online course to become an Algorand developer? Yes, you are here right now. This is the best way to be a developer. And as Camilo mentioned in the chat, I forgot to mention at the top here that you will be getting a certificate for attending these boot camps. So we don't have courses on other sites like Udemy or other self-learning sites yet. But here's where you can go. You can learn Algorand, and then after you come here, we'll give you resources to where you go to keep continue your learning journey. So I think that covers all of the questions. And so I am going to be, actually we just saw two more. They're ditching Golang. No, we still support Golang natively. Like our node implementation is written in Go, and we also have an SDK available in Go. And we're actually going to be working to better support Go and have more features available in our Go SDKs. So we haven't forgotten about Golang, but for smart contracts right now, we just support TypeScript and Python. And no, for the TypeScript and the Python bootcamps, they're going to be the exact same content. We're writing the exact same smart contract. We're going to be using the exact same front end. The only difference is what language we're going to be writing our smart contracts and our test for smart contracts in. So the thing you're building is going to be the exact same. The main two differences between languages is that Python is our official production ready language, and TypeScript is still a work in progress. So if you want to build a production app right now, we'd recommend you go with Python. However, if you prefer using TypeScript as a developer, all the same features are still available. You can build the same exact apps as we'll be doing in our bootcamps, but it's not yet production ready, so there might be some breaking changes in the near future. So really right now, your decision mostly should come down to, do you prefer TypeScript or Python? In the near future, like in next couple months, like 6 months from now, maybe sometime later this year, we'll have TypeScript ready for production as well. So it comes down to your preferred language. Okay, I'm going to answer this question, and then I'll be answering the rest of the questions asynchronously in the questions tab. What atomic transfers mean is that I can tie two transactions together to ensure that they happen at the same time. So if I want to buy a car from you, I don't just send you the money and hope that you give me the car at some point later in the day. We do those things at the same time, right? I give you the money, you give me the car. On distributed systems, it's typically hard to do that. But on Algorand, we have ways to guarantee that the transaction actually took place. So to use that car analogy, on Algorand, I can guarantee that I only give you the money if you give me the car. And likewise, I'm only giving you the car if you give me the money. So it's a way to guarantee that two ends of the deal, or could actually be multiple ends of the deal, occur at the same time. And we'll actually be learning more about this and how we do it in this video. So I'm going to go ahead and continue on playing the video with the content and the code. I'll continue to answer questions in the questions tab. And if we feel like we need to stop again, I will go ahead and stop and answer more questions live like I'm doing now. For now, I'll go ahead and continue the video.
.com/Algorand-bootcamp. You can find this organization that has the following README. And what you want to do is you want to go down to the English section and go to this intro EN repository here. And this is going to have a very basic repository that we can use to begin exploring Algorand. This is a repository that's set up that has very minimal dependencies and installs AlgoKit for you in a code space. If you already have AlgoKit installed on a local machine, you can clone it locally, but this is going to be for those that don't yet have AlgoKit installed. If you don't know what AlgoKit is, we'll be learning about it in the next introductory video. But for right now, all we need to do is go to the intro EN repository, hit the code drop down here, and then click create code space on main. And what this is going to do is it's going to create a virtual environment in the cloud that you can use to begin exploring Algorand. This is going to have our AlgoKit tool installed for you, so you don't need to install any dependencies in order to get started. So as you can see here, we've in our browser loaded up an instance of VS Code. And in just a minute, we should see the terminal start to run some commands for us. And we can see here that we are running AlgoKit install, or pipx install AlgoKit. And this is installing the AlgoKit tools for us. And then after this runs, we're going to do what's called an AlgoKit local net start. And this is going to start a local network that we can send our transactions on. In this video, we're going to be using the SDK to create accounts and send some transactions, create some assets, do a couple different sort of fun things. But all that is going to need to be powered by a network. Instead of using a public network like mainnet or testnet, we're going to be using a local network that is going to be running locally here in my VS Code code spaces. So because we're in a code space, the only thing you need to do is start the code space, wait for these two commands. Let me actually make my screen bigger. Let me see if I can actually collapse this. There we go. Make this one up bigger and make this a little bit smaller. And once this command is done, then we can start playing around with it. I do want to give a quick disclaimer.
Okay, so I see a question about how we can start the code space, and this is a good time to pause and make sure that everyone that wants to launch the code space and follow along can do so. So what I'm going to do is just give me 1 second and I will share my screen. Share screen. Share my window. Okay. So if we go to github.com/Algorand-bootcamp, and I have shared these links in the chat of the live storm. So you can either come to Algorand bootcamp yourself, or you can check the chat for the links there. And what we're going to do is when you go to Algorand Bootcamp, you'll see this README file here with all of our previous bootcamps. But at the top here is our intro bootcamp and a link to the repository. And then in here, I just realized I forgot to do the README, so I'll be sure to update the README. So for those that are watching the recording, I'll add a README describing this. But basically, all you need to do is first you need to make sure you have a GitHub account. If you don't yet have a GitHub account, it should be pretty quick to make one. You will need a GitHub account in order to start the code space. And once you're logged into GitHub, if you drop down this green code, so let me delete this, you can see what it'll look like. If you drop down on this green code button here, you should see no code spaces. You don't have any code spaces, and then create a code space on main. And so if I click create a code space on main, what that's going to do, it's going to set up that virtual environment for me. So we have our library and everything that we're going to be doing in this session ready to go. So again, make sure you're logged into GitHub. You do the drop down to the code spaces and then create your code space on main. And once you have created it, when you come back, you should be able to open up your code space and continue where you left off if you need to take a break. So that is how the, let me go back to the intro. So that is how the code spaces work. So let me stop sharing here. And I'll give it a minute to see if we have any more questions about starting the code spaces. And while I'll give people a minute to catch up, I will answer some questions. So can we push or pull from REST API to create hybrid real-world transactions? So please feel free to ask again if I'm misinterpreting your question, but I think what you're asking here is, can you use a mixture of blockchain and some external API when building on Algorand? So you cannot use an external API in a smart contract. When you execute a smart contract, it gets executed in the Algorand virtual machine, which does not have access to external APIs. However, of course, if you are integrating, a Python backend or a TypeScript backend or a Go backend or any other backend, you can integrate your APIs in with our Algorand SDKs and do whatever you need to do to bring those two together. So we don't support APIs in smart contracts, but of course, in any language that has the Algorand API, which I should mention is TypeScript and Python, of course. We also have a Golang API and a Java API. and those are our official APIs. But then we also have some community APIs like Dart, for example. And if you want more information about all the different APIs, and we have a .NET API as well. But if you want more information on like the community APIs and the developer APIs that we as a foundation offer, then join our Discord and you can get much more detailed information about all the different ways we can interact with the chain. Okay, so let me see. Okay, so we're not going to be going over installing AlgoKit in today's session. Right now, we're just going to let our code space do that automatically. We'll be going over AlgoKit installation and just general development environment setup Thursday, so an intro session 2. So we'll be covering that then. For now, I'll briefly cover some AlgoKit commands, but we're not going to be going too in-depth on it. We're just going to be focusing on the SDK to start. And okay, so if you aren't seeing a code space button, you want to make sure that you're signed in. If you aren't signed in, I don't think you'll be able to see it. I can check this right now. Let me give me 1 second. Yeah, so if you aren't signed in, when you do the code dropdown, you'll only see the clone HTTPS and GitHub CLI. So you want to make sure you're signed in. And if you still aren't seeing it, maybe trying refreshing. And then you do the dropdown. So let me share my screen again. So if you do the dropdown, if you're not signed in, you only see this local tab. You won't even see the code spaces tab. But once you signed in, when you do the dropdown, you want to make sure you click on the code spaces tab, and then you should be able to create a code space from here. If you're still having problems, I don't want to hold up the whole session too much. So if you're still having problems, don't worry, this is going to be recorded. And then after this, so after we get through the recording for everyone, we can go through some more specific troubleshooting steps if you're still having problems. So don't worry if you can't get it working right away. I'll help you to get caught up for the later sessions. Okay. And I think that covers the questions we have now. So let me stop sharing, make this big, and I'll continue on the video. And as always, if you have more questions that I need to stop it for, I'll do so.
Repo should look pretty much like this, except you shouldn't see this tarball here. I have this here because I'm running a pre-release version of AlgoKit before it's been released as I'm recording this. But by the time you get to this video, it'll be released and the tarball won't need to be here. But everything else should look the same. And if you're a TypeScript developer, this should look pretty familiar to you. We have our package JSON file that has our dependencies. And then in source, we have an index.ts file. And this is where we're going to be writing all of our code today. And so as you can see, the first thing we need to do when we're interacting with Algorand is import our dependencies, of course. And right now, the main dependency that you're going to be using when you interact with the chain is called AlgoKit Utils. And you can see here that we have this library called Algorand Foundation, AlgoKit Utils, and we're importing everything that AlgoKit Utils has to offer under the namespace AlgoKit. So right away, I am importing the library that I need to interact with the chain, and I can go ahead and get started. Now, the first thing you want to do when you begin interacting with the chain and writing your Algorand codebase is you want to instantiate what we call an Algorand client. To do this, we're going to create a variable called Algorand, and we're going to say this is going to be an AlgoKit dot, and I just realized I'm not getting my IntelliSense because I need to run npm I. So I'm going to go ahead and install my dependencies. And now, if we go ahead and do an AlgoKit dot, we should see all the things that Algorand has to offer. And up top here, our Algorand client. And we're not going to instantiate that directly. What we're going to do is we are going to instantiate from default localnet. So AlgoKit.Algorand client .default localnet. And what this is going to do is give us the default localnet client for interacting with Algorand. So what does default localnet mean? As I said, we're going to be interacting with a local network that's running in our code space. We're not going to be using mainnet or testnet. And because we're using something that's running locally, we know how to connect to it. So there are various different components that we're connecting to here. We don't need to go into it right now, but the key is that using this default localnet will connect you to, if we go over here to the ports, these services that are running in our VS Code code space. So now, I opened the wrong thing. So now that we have this Algorand client, we can start doing Algorand things. And the first thing I want to do is I want to create some accounts. And I'm going to create 2 accounts here. I'm going to say const Alice. So I'm going to make one account called Alice. And I'm going to use my Algorand client. And the Algorand client is split up into multiple different properties that contain different things. And so what I want to do is I want to create an account. So I know I do Algorand.account. And I'm going to say .random. And what this is going to do, it's going to generate me a random account, and I'm going to save that in the Alice variable. Okay. And now I'm going to generate another random account called Bob, and I'm also going to save that in a variable. And that's going to be generating using the random command. Now, once I have an account, I want to see some information about that account. So I'm going to do a console.log. Close out of that so we can focus more on the code here. Probably make it even one bigger. We're going to do a console.log. I'm going to say this is Alice's address. And I'm going to log alice.address. And if I go ahead and do an npx tsx src/index. What I can see here is that Alice has a unique Algorand address. This 58-character base 32 address is what Algorand addresses look like. And if I run the script again, because we're using .random to generate Alice's account, her account address is going to be different each time. Okay, so we got our address. Now, how do we actually get information about Alice? So if I do a console.log, and I'm going to say, oops, close out the terminal here, Alice's account. So I'm going to get her account information from the ledger. I'm going to do an asynchronous call to Algorand.account. Again, anytime I'm doing something with an account, I can call it .account. And what I want to do is I want to get the information about Alice's account. I'm going to specify alice.adder. Actually, let me zoom out one more here. So I've generated an account called Alice, and that's going to be a random address as we've seen. And then I'm going to log her address, and then I'm going to log information about her account. So let's go ahead and see what that looks like. I do an npx tsx source index. Well, you can see here that we have a bunch of information about Alice's account. We now have not only her address now, how much algo she holds, her minimum balance, which we'll get into later today, and a bunch of other information about Alice's account. As you can notice here, everything is either 0 or undefined or an empty array. And that's because Alice's account doesn't actually exist in the ledger. We've just created Alice's account using this .random method. So the only thing that knows about this account is my local script. And as soon as the script exits, that account is now lost forever. So what I want to do is I want to put Alice's account in the ledger.
Yeah, so I see some people in the chat talking about our dependencies. So let me share my screen and just show you real quick what we have to do to get set up. Window, there we go. Okay, so again, we're going to start off by doing the drop down, and we're going to start a code space. And if we open up our code space, we should see what is a VS Code window here. And now, some people are asking about running this locally. You can clone and run this locally if you want to, but for the intro, we're going to be using code spaces just to get you started and start playing with Algorand without having to worry about your environment setup. And then in intro session 2, which will be Thursday, which everyone here is automatically registered, so you'll get the link to that sent to you automatically. And in session 2, we'll be going over development environment setup and how AlgoKit works in particular. So I saw some people were saying if they do an MPX TSX source, if you try to run it right away, what's going to happen is, no, looks like it, oh, because I haven't actually imported it yet. But what you'll need to do if you try to, add the code and then it doesn't work, you need to make sure you do an npm I. So you can see here, that VS Code is giving me an error. So I want to make sure that I do an npm I to install all of my dependencies. And that will ensure that we have our dependencies installed and we can go ahead and get started. So I'll put that command in the chat. npm I. Okay, and I'll stop sharing. Okay, so in this intro session, we're going to be using TypeScript because we're actually going to be using it in both the Python session and the JavaScript session for our front end. However, because this is just the intro, this is not yet the Python Bootcamp. The Python Bootcamp is going to be next week when we are using Python to write our smart contracts. So we're going to be using JavaScript for the intro right now because this is a language that's going to be used in both bootcamps for our front end. We're going to be using TypeScript and React for our front end in particular. Now, if you are just interested in Python and you don't want to have anything to do with TypeScript, no worries. You can register for Python bootcamps and just attend the first 2 sessions, which will be nothing but Python. But then we'll do front-end integration, which is going to be with TypeScript as well. So if you don't like TypeScript at all, don't want to touch it, we're going to be using it today, yes, but in our Python bootcamps, we're not going to be forcing you to use it. So we'll be doing all Python then. But today is just the intro where we're talking about Algorand in generally and how we interact with the chain. And we're using TypeScript because that's the common language that we use for our front-end integration, and that we'll be using in our bootcamps going forward. Okay, so I'll go ahead and continue the video.
Now, the best way to do this is or in fact, the only way to do this is to give Alice's account some algo. So what I want to do is I want to somehow get algo into Alice's account. Now, because we're on LocalNet, we don't need to go to a dispenser website, and we can just programmatically get a dispenser account. For those that aren't familiar with blockchain development, a dispenser is basically an account that we can use to fund other accounts. So I'm going to save a dispenser account in a variable. Dispenser equals await Algorand.account.dispenser. What this is going to do is it's going to, in my dispenser variable, give me an account that can fund Alice. And so now what I'm going to do is send money, or in particular, send Algo from the dispenser account to Alice. I'm going to do an await Algorand.send. And so whenever I want to send the transaction, I do .send, and I'm going to be sending a payment. And now in here, I define who is sending the payment. That's going to be the dispenser address. Who is going to be receiving it? That is going to be the Alice address. And then I'm specifying the amount. And let's just say we're going to specify 10 algos. So this is one important feature of AlgoKit. In Algorand development, all the low-level tools use microalgo, which is 1 times 10 to the -6 algo. However, for end users, we generally like to think in algos. So AlgoKit provides this algos feature that allows us to generate an algo amount. So we could specify either 10 algos or 10 to the 6 microalgos. Both these things are the same thing. AlgoKit will do the conversion for us. To keep things simple, I'm going to keep it as algokit.algos. Okay, so at this point, we've created Alice, and we've seen that she isn't in the ledger yet. She has a balance of 0. And then what we did is we sent a payment over the network in order to send Algo from the dispenser account to Alice's account. And now what we can do is let's console log Alice's account once again. I was waiting for my copilot to kick in. Algorand.account.get information, and then Alice.address. Okay, so await Algorand account get information Alice address, just like before. However, this time, if we run it, give it a second to run, what we'll see if we scroll up is we'll now see Alice has 10 algo, or what would this be? 100,000. Yeah, 10 million algo. Okay. So we know that we have 10 million algo in Alice's account, and this account is officially in the ledger. Now, the next thing I want to do is create a token. Now, before I go into the code to create a token, I want to jump back to my presentation here and talk a little bit about how tokens work on Algorand. Now, I mentioned that Algorand supports native tokens. When we want to create a token, whether it's a fungible token or a non-fungible token, we don't need a smart contract. Instead, we can use what we call an Algorand standard asset, and this is commonly abbreviated as ASA. And what ASAs allow is us, as I said, to create tokens without a contract, but still have some programmability. For example, ASAs feature all of these optional features. These aren't features you have to enable. Not every token has these enabled, and you can check whether they are enabled. But these are some of the features that are allowable. One of which is called clawback, and this allows tokens to be revoked. The other is freeze, which allows token to be frozen. And then we can associate verifiable metadata to our tokens. So in blockchain, we don't want to upload, huge image files to the chain, but we want to associate our tokens with an image so we can see something pretty when we look in our wallet. What the verifiable metadata means is that we can point to some off-chain image and verify that that off-chain image is indeed the image that we want to display. Now, we aren't going to be going into all of these features here in this introduction course, but I wanted to mention that just because we aren't using smart contracts doesn't mean we don't have these advanced features. And these features in particular are features that are essential for regulated assets. For example, USDC cannot be deployed on a chain if the asset cannot be frozen. And this is natively supported by Algorand standard assets. Now, going beyond these basic asset functionalities, we also have arcs that exist on top of them. And again, we are not going to be going into these arcs today, But I want to point out that there is a lot of flexibility of things you can do with Algorand standard assets. If you are someone that is interested in creating an asset, these are the standards you should keep an eye out on. There's ARC3 for immutable tokens, so these can be fungible or non-fungible. Then ARC19 for mutable tokens, which can be fungible or non-fungible. And both of these are inspired by ERCs, and they use a lot of the same JSON formatting as ERCs on Ethereum. For those that aren't familiar, ARC stands for Algorand Request for Comment. ERC stands for Ethereum Request for Comment. And both of these are ways for communities to define standards within their ecosystem. And because Ethereum became before Algorand, we could take what they learned in Ethereum and improve upon it. And that's how we got to ARC3 and ARC19. So again, we're not going to be covering these in-depth details here in this intro video, but I wanted to make sure that you know that you have all this flexibility with assets. So let's go back to our code here. And let's talk about how we can actually mint a token. So I am going to do await Algorand.send. Again, anytime I'm sending a transaction to the network, I'm doing something on chain, I do a .send. And I'm going to see what my options are for asset. And I can see here that I have a create option. So in this asset create, I'm going to define the sender, and that's going to be Alice. So I'm going to have Alice create an asset. And the only field we need to define here is how much of that asset we want to define. Like I said, we could define other fields like the name of the asset or the URL or the metadata hash, all sorts of things that we can do. But we're going to keep things very simple for this intro course. We're just going to create an asset. It doesn't have a name, and we're going to mint 100 of it. Now, the important thing is, once we mint this, we need to know how we refer to the asset. On some other chains, because assets are smart contracts, assets just have a unique token address. On Algorand, each asset that you create has a unique UN64 identifier. And to get that, we need to get the return result from our create. So I'm going to say const create result equals the send asset create. And then what I'm going to do is I'm going to log the create result. And let's just take a look at this. This is going to be logging a lot. And normally in production, you wouldn't need to log this much, but I'm just logging here to show you a little bit about what's going on. If we come all the way up to our create result, we can see here, here's our transaction and all the fields that AlgoKit automatically filled in for us. And in particular, we have our .confirmation, and this is going to contain the index of our asset, the ID of our asset. So I know when I sent this create result, the asset index was 1003. So what I want to do is I want to save asset ID. That's going to be create result confirmation dot asset index. And I'm going to hit it with an exclamation mark because I'm telling my IDE I know that this is defined. And now if I do a console.log of my asset ID, let me just get rid of this so we can declutter the console a bit. I can now see that I ran this script again, and the asset I just minted was asset ID 1005. And once we have the asset ID, we can then begin to use it. So let's talk about how we transfer assets. And before you just copy this code and close the video, the code I'm about to write will throw an error. It will not work. But I want to walk you through why, so I'll show you it not working first. So I know to send a payment, I do await algorand.send.payment. To send an asset, I do algorand.send.asset transfer. And here, the sender is going to be Alice, the receiver is going to be Bob, and the amount is going to be, let's say, 1. I'm going to send 1 asset to Bob. And then we need to specify our asset ID. And I forgot, we just need to specify that this is a big int. And this is important in AlgoKit. Most of the time when you're working with fields that are numbers, you're going to be passing in a big int. And the reason is because natively, all numeric values on Algorand are uint64s. So 2 to the 64. By default, JavaScript, and thus TypeScript, only support 2 to the 53. So it's possible that we would have a value that is larger than what JavaScript supports, and this wouldn't throw an error, this would just silently fail. So it's very important that when we're working with unsigned 64-bit integers that are larger than the max integer that JavaScript knows how to work with, that we use our big ints. So we're going to convert our asset index into a big int, and when we specify our mount, we are also using a big int. I should call out the fact that in the somewhat near future, so I'm recording this end of March, beginning of April, right now, we have to do some manual conversion between numbers and big ints. In the future, much more of the library will be supporting big ints, so you won't have to do as much manual conversion. But if you ever get an error about numbers versus big ints, you might have to do some manual conversion like we just did. So at first glance, this looks like it's going to work, right? We're doing a send transaction. We're sending one asset of our asset ID from Alice to Bob. Let's go ahead and try to run this. And we'll see, okay, we got a status 400 and we see this error. And this error is telling us that the receiver must opt in. So before I can send this asset to Bob, Bob has to opt in. So what does opting in mean? To explain opting in, I'm going to go back to our slides and take a step back and explain this concept of minimum balance requirement. So on Algorand, every single account has a minimum balance that it must maintain. Any transaction that puts that account below that minimum balance is going to get rejected. And the default starting account MBR is 0.1 Algo. And in fact, if we actually go look, and I take a back look at this min balance field here that I'm logging, you can see that even when Alice had 0 Algo, the ledger, or excuse me, the API told us that the minimum balance to be in the ledger is 100,000 micro Algo. So if I tried to send Alice less than 100,000 micro Algo, or 0.1 Algo, so let me say 0.01, and let me run this, and we can see here that even though this is a brand new account that I'm sending funds to, that it's not enough. I need to send at least 100,000. I'm going to go back to sending her 10. And so what this means is that an account is only in the ledger if it has 0.1 Algo, and it can't go below 0.1 Algo unless we bring it to 0 Algo, in which case we're deleting that account from the ledger. Anything associated with that account is going to be deleted from the ledger, and we are not going to have a minimum balance requirement, and we're not going to have a balance. So this is a very important concept to remember, that every account starts off with needing 0.1 Algo to be in the ledger, but as we do more things with that account, the amount is going to go up. And in particular, the minimum balance requirement, or MBR, increases when the database size increases. So anytime the size of my account in the database gets bigger, I need to pay for that space. You can think of this like renting that space. Okay, so you're probably wondering, how does minimum balance requirement relate to opt-in? The reason that Bob needs to do what we call an opt-in is so that he can increase his MBR to pay for that space. When he receives that asset, the size of his account in the database increases because there's a new entry containing a uint64 that has the balance of his account. So we need to pay for that increase in the database. And the way we do that is by an asset opt-in transaction. So you can see here, this is a table of all the different things that can change the minimum balance requirement of an account. The two highlighted here are what's related to assets. So our asset opt-in means the sender has to increase their minimum balance requirement by 0.1 algo, but they can undo it and decrease it by 0.1 algo as well. So in order for Bob to receive that asset, first he has to be in the ledger. And in order to be in the ledger, he needs 0.1 algo. Next, we need that account to increase its minimum balance requirement and opt into the asset by increasing its minimum balance requirement by another 0.1 algo. So we need Bob to have at least 0.2 algo. So let's go back to our code. And what I'm going to do is now I am going to say, we're going to fund Bob. So I'm going to say, let's await. Actually, let me do this before our asset transfer. Algorand dot send payment. And what we're going to do is we're going to send from the dispenser, dispenser address. We're going to be receiving in the Bob account. And the amount, we're also going to send Bob AlgoKit Algos 10. Okay, so we now have enough algo in Bob's account, but if I were to try to run this again, we're still going to get the same error that we must opt in. So we've created Bob's account and he now has 10 algo, but his minimum balance is still 100,000. It's still 0.1 algo. And so what we need to do is we need to increase the minimum balance so Bob can receive the asset. In other words, we need to tell the chain that Bob wants to be able to receive this asset. So we're going to do an await Algorand.send asset opt-in. And in here, we're going to say the sender is the Bob address, and we're going to pass in our asset ID. Oh, and excuse me, this should go in front of the transfer. So now we've given Bob algos and we've increased his minimum balance requirement. Okay, so actually, let me log this. Console log Bob's MBR pre opt-in. We're going to await Algorand.account.get information Bob.adder. And that there, and we're going to call min balance on that. And then we're going to take a look at Bob's MBR post opt-in. And so we can see now that if we run this, that Bob, that first of all, that this was successful. And we can see after we sent Bob algos, his minimum balance requirement was still 100,000 or 0.1 algo. And then we sent the asset opt-in and his MBR now increased to 200,000 or 0.2 algo.
Okay, I'm going to pause it real quick to talk about this great question here about transaction signing. So yes, on Algorand, we still need to sign our transactions. On Algorand, we use a little bit of details here. We use a key pair, AlgoRand 25519 key pair for signing transactions. And so every time we submit a transaction to the network, we need to sign it in order for the network to accept it with our private key. Now, in this intro course, because we're just using our local net and we're using our Algorand client, the Algorand client is doing the signing in the background for us. So for this particular content, we don't need to explicitly do the signing because all of our accounts are generated locally and our Algorand client is able to figure out the private keys because they were generated locally. However, if in our future bootcamps, so in our smart contract bootcamps for Python and TypeScript, we'll be going a little bit more about how signing actually works with like external wallets. So on Algorand, we have a couple of mobile wallets such as Pedro Wallet and DFly, and we'll be talking about how we do transaction signing with those wallets. And in that case, we do need to make sure that we explicitly set up our signing correctly. But for today's intro class, yes, the transactions are still being signed, but it's happening in the background by the Algo client for us. So we don't, as developers, don't have to explicitly do the signing. The Algorand client does allow you to specify ways to do custom signing on transactions, but because this is an introductory course, we're just keeping things simple and letting Algorand client do the signing for us. So we'll be getting more into signing in our future beginner boot camps. So great question. Go ahead and continue the video.
And now finally, we can send the asset to Bob. And what we can do is we can now take a look at Alice's and Bob's accounts to make sure that their balances are what we expect. So I'm going to say Alice's assets. I'm going to say Alice asset balance. And we're going to await Algorand again. Anytime we're doing something with an account, we do a .account. And we're going to get asset information. And we're going to pass Alice's address and then the asset ID. So we're going to log Alice's asset balance, and we're going to log Bob's asset balance. And we're going to go ahead here and we can see, oh, and I forgot to change this line here. So we're going to be logging for Bob. And we can see here that after our transfer, so remember we initially minted 100 and then Bob opted in. And now we've transferred one asset from Alice to Bob. Okay, now this is great. And however, if we go back, oh, that was the wrong screen. If we go back, we can recall that one of our later one features is atomic transfers. So let's talk a little bit about how we do atomic transfers and how they could be useful. So let's say that, okay, so Alice sent Bob one of the assets. But let's say now, and she was just being generous, but let's say now she wants that asset back, but Bob refuses to give it unless Alice pays her. So what we want to happen is we want Bob to send Alice the address, the asset, and we want Alice to send Bob some Algo. So what we want to happen is we want Alice to pay Bob to get the asset back. Now, we could do this. We could await Algorand.send payment. And this is going to be from Alice to Bob. The amount, say it's for one Algo. Or, excuse me, this should be AlgoKit Algos 1. And then let's say Bob agrees to send an asset transfer. And it's going to be Bob address, asset ID, receiver, Alice address, and amount. We'll send back that one. Right, so we have these two transactions that if we log it again here, we can see that we indeed, we sent the asset back, right? All is good. But what happens if Alice sends her Algo and Bob decides to not send his asset transfer, right? So Alice sends the Algo, but Bob still holds on to the asset. For Alice, she wants to make sure that she's not just sending her Algo and Bob's not running away with it. And for Bob, he wants to make sure that he's sending his asset and getting something in return. So what we want to do is we basically want to combine these two things into one atomic unit of work, or as we call it on Algorand, an atomic transaction group. And to do this, we're going to do Algorand.newGroup, and we're going to add our transactions to the group. So I'm going to add payment, and then add asset, oops, not config, asset transfer. So let me actually uncomment these and copy out our fields here just to save a little bit of time. So this is going to be our payment. And then we're going to have our transfer. So the same exact code, or excuse me, same exact like transaction fields, except now we've composed them together using this new group. So we've created a new group. We're adding a payment to the group. We're adding an asset transfer to the group. And we can go ahead and we can see that it worked. I forgot, once we form the group, we need to execute it as well. So await. And now that we've actually executed the group, we can see that Alice has indeed got her asset back, and Bob and Alice sent Bob some money as well. So using atomic payments, we ensured that both parties can agree upon a transaction, but neither party has to do anything if the other party follows through. So we're guaranteeing that both parties hold up their end of the bargain without having to involve any smart contracts. Okay, so now what we want to do is Bob no longer holds the asset. He has 0, 0 of the asset. But if we come up here and we actually Bob's MBR, see Bob's MBR post transfer. So we'll see here that Bob still has 0 of the asset in his account, but his minimum balance is still 2000 or 0.2 microalgo. What we want Bob to do is we want Bob to get rid of that minimum balance requirement. So again, come back here. We can see when we opt in, we increase by 0.1 algo, but we can opt out, which will decrease it by 0.1 algo. And so what we want to do is we want to send an asset transfer from Bob. So await Algorand.send asset transfer. And our sender is going to be Bob. Our receiver will be Alice. And we're going to say asset ID is that. Our amount, we know we have 0, so we're just going to say amount 0n. And now if we were to just do this, post opt out. If we were to just do that, let's see the transaction goes through, but his minimum balance doesn't change. What we need to do is add this explicit field, close asset to, and we're going to close to Alice. Now what closing means is we're going to get whatever is left in my account and send it to this address. So to actually demonstrate this, what I'm going to do, so I'm going to go all the way back up here. I'm going to transfer 2 of the asset to Bob initially. So Alice sends Bob 2 assets, and then Bob sends her back 1. And then, so let me comment this out. So let's see where we're at right now. So Bob originally has 2, he sends 1 back. So now at this point, Bob has 1 of the asset and his minimum balance is still 200,000. If Bob wants to get rid of all of his assets, he can do a closeout. And what this will do is it will send all of the remaining assets to whatever address we specify here. So if I go ahead and run this again, we expected that actually. Let me log this. So now we can see that after doing this close, that Alice now back has 100,000, even though our amount we transferred was 0, we specified the close asset to. So all of our remaining assets went to Alice. And then because we did a close, we decreased our minimum balance requirement by opting out.
Okay, so that concludes the content for today. Apologies for the abrupt ending. I just wanted to have a slightly different ending here for the live content, so we can discuss a little bit more about what's upcoming and talk about what we have. So at this point, we've kind of gone through the core features of Algorand. And in the chat, if you want to see the completed code, it is in the intro EN repo that was shared earlier, just in a different branch. Again, I'll update the README to properly point you in the right direction. But what we want to do now is talk a little bit about what's coming up, what we need to ready for our next sessions. And then, so we have our session 2 on Thursday. So everyone here is automatically registered for that. So you shouldn't need to do anything on your end. You'll get an email automatically for that. And then I've seen a lot of questions about, like, I thought we were learning Python here. Why are we doing TypeScript? So in this intro course, we're using TypeScript to just learn the basics of Algorand, because TypeScript is the most common language for our front ends. And then in our beginner boot camps, we will be covering how to use Python to write our smart contracts and test it. So we're actually doing a lot of the similar things that we did today in TypeScript in Python as well. The reason we went with TypeScript is because it's more common for front ends, and we'll actually be using TypeScript in the Python series as well for our front end. But again, if you are just a Python developer, you loathe using TypeScript, you will be able to just join for the Python side of things if you would like. So, Camilo, were you able to share our dates for our upcoming bootcamps?
Absolutely. Hold on a second, please. Thank you, Joe. It was an amazing session. We learned how we can create accounts, add balance, create asset, make the team. And there are too many things that we need to keep practice to understand in a full detail. But over here, we have our upcoming bootcamp. So if you are a Python developer, please join us in the beginner bootcamp the next week. On April 22nd, we will have the beginner TypeScript, and after that, we will have the intermediate content. So please join us, share the registration info with your friends. We are creating all this amazing content just for you. So I'm super excited. How do you feel today? You can share with us what do you learn, what do you feel in the chat?
Yeah, definitely. And of course, between today and Thursday, if anyone has any questions about the content that we went over today or what we're going to be doing on Thursday, you can join our Discord. So let me put that link in the chat. It's discord.gg/Algorand. So pretty easy to get to. And in the Discord, you can find myself and all of our colleagues over at the foundation. They're happy to answer questions, whether it's about the bootcamp or not. So that's the place to go if you're a developer on Algorand. So I got about 5 minutes left before we wrap up this session. So what I want to do is actually first let me check.
Yeah, there are one important question, and you will receive the recording into your email after the session ends. So for that reason, we use Livestore because allow us to share with you the recording. So you will receive it in the same email that you used to register. It's important to mention also that automatically you are registered for the session 2 that is going to take place on Thursday. And what else? Don't forget to subscribe to our AlgoDevs YouTube channel and to help us to share the screenshots on X. You can tag us, and that's all I want to share with you guys.
Yeah, I think one thing, there's a good question about AlgoKit. So this is a good segue into what we're going to be doing on Thursday. So in today's session, we just used code spaces. So you don't have to worry about setting up your development environment. You can just get started right away with the code. But for our later boot camps, we encourage you, instead of using code spaces, to install everything locally. And that is going to be the focus on Thursday's session. That's going to be much less like presentation content and more so I'll be running through what you need to do to install AlgoKit and just making ourselves available to help you troubleshoot and make sure that your dev environment is all set up. So on Thursday, we'll be going over how to install AlgoKit 2.0 and make sure you have all your dependencies. So we'll be covering that in depth on Thursday. But kind of a high level thing, you need to have Python 3.12, and from there you can install pipx and AlgoKit, and then you also need Docker to run your local net. But we'll be going into the details on how to do that on both Mac and Windows on Thursday. So stay tuned for that.
We have one question about how long is going to take the session for Python. The Python content is going to be around maximum 2 hours. So it's going to be from Monday to Thursday next week. So please join us and help us to invite a lot of people to participate, because this is going to be the first Python bootcamp that we are going to have.
Yeah, definitely. If you again, if you love Python, that's the bootcamp to go to. And as Camilo mentioned, we'll have 4 sessions. The first 2 sessions are going to be pure Python, writing the contract and then testing it in Python. And then the next 2 sessions are going to be about front-end integration. So we're going to be using Typescript and React for that. If you are just interested in the Python side of things and don't care about the front-end integration, of course, you don't need to attend those later 2 sessions, but make sure you still sign up for the Python Bootcamp if you are interested in Python.
It's important to mention that we're going to have a certificate of participation. So the people that participate in both sessions will receive, and the next session we are going to share with you the link so you can claim the certificate. So that is the other important thing to participate in the session number 2. What else? There is one question that if we're going to have an event in Paris Blockchain Week. Yes, we're going to have an event. If you want, I can share with you guys the registration link, the next session, because I don't have right now it.
Yes, I know Silvio, the founder of Algorand, will be there giving a talk. I think it's called the Blockchain for Governments or something along that line. So it will be a pretty exciting talk. So if you're in the area, definitely stop by.
Yeah, hold on a second. I'm trying to look the registration link for you. So maybe it's over here. Yeah. So okay. So thank you so much, Joe. Thank you guys for joining us. We are super excited to keep working with you and keep learning and start this journey to become Algo Dev.
Thanks, Camilo, and thanks everyone for watching. Hope to see you on Thursday.
Bye.